Depth First Search, or DFS, is a graph traversal algorithm that explores as far as possible along each branch before backtracking. It digs deep into a path before moving on to the next unvisited branch. Let's break it down with an example. Imagine starting with an unvisited graph. We begin the traversal by choosing a starting vertex and visiting it first. From there, we visit one of its neighbors. Then, instead of visiting all other neighbors, we dive further into that neighbor's own neighbors until we reach a vertex with no unvisited neighbors. At this point, we backtrack and start exploring other branches. In this example, we will backtrack only one vertex since vertex 1 still has unvisited neighbors and visit nodes 4 and 2. Next, we will visit 6 since it is a neighbor of 4, followed by 5, which is the last remaining neighbor of 1. Notice the traversal order here. DFS works by going as deep as possible along one path, only backtracking when no further vertices remain on that path. This traversal style resembles the last in, first out structure of a stack. And speaking of stacks, the DFS implementation relies on 1. You see, code-wise, we begin by pushing the starting vertex onto the stack. Then we pop the top of the stack, mark the vertex popped as visited, and push its unvisited neighbors onto the stack. These 3 steps, popping the top of the stack, marking the popped vertex as visited, and adding its unvisited neighbors to the stack, are repeated until the stack is empty, which signals that the graph has been fully traversed. But wait, the output we just got isn't exactly similar to the previous one. And that's okay, because both these traversals are considered correct DFS traversals. You see, the difference is that in the stack example, we added all the neighbors at once. Hence, the vertex the algorithm had to pop and start with was vertex 6 on the far right. Whereas in the first example we gave, we explored vertices starting from vertex 1 on the far left. Check out the full video pinned in the comments section.